So since last few days we are trying to work out the analysis of the circuits which consist of reactive elements by bypassing the solutions of differential equations. We will go through that by all different ways, but at an initial stage, to make everybody comfortable, we are having a simple presumption that when there is one reactive element, something like e raised to lambda t with some constant comes into picture. What is the reason for that? Straight away, e raised to lambda t is an in general function. When differentiated, e raised to lambda t remains there. Again repeat, why we presume that solution? For linear differential equations, what do we have? Whenever we have got ft is equal to that constant that is not that way material, but we can have say b e raised to lambda t. In each time we differentiate f dash t, f double dash t, what we get? E raised, that we have discussed in the first time also, again we are discussing, e raised to lambda t remains there. So ft, f dash t, f double dash t, then its integration all are some multiples of ft itself, and because of that only a linear differential equation can be satisfied. For some other solution, say t square, log t, for such solutions the differential equation which we are writing cannot be satisfied. Are you getting me? E raised to lambda t is a kind of function whose derivatives or whose differentials and integrals are scalings of it. Therefore, the solution takes up that form. Then one may ask, why that a plus b raised to lambda t? Because the differential equation is not directly involving those differential and actual terms, it also involving some constants. So as to take care of that, we add a. So in general, for one reactive element, we add one e raised to lambda t. So with this new presumption, we try to see whether we are able to solve the problems. When we have one reactive element, we have e raised to lambda, one e raised to lambda t. If we have two reactive elements, e raised to lambda 1t and e raised to lambda 2t. With this, we can very easily proceed, and this solution applies to at every point in the circuit, the voltage of this form. At every point, a, b, c lambdas may change, but it is a plus b e raised to lambda 1t plus c e raised to lambda 2t. So in this case, only a, b and c will change. At any point whenever you find the voltage or current, it will be of this form: a plus b e raised to lambda 1t plus c e raised to lambda 2t if we are having two reactive elements. So we were talking about the situation where we had two reactive elements, and we were finding that we are somewhat stuck up there. We try to proceed further on the same problem, because that solution is very much important for us, because that will give us an insight how to work with various complicated circuits, and we should be very much comfortable in that. There should not be any problem the moment at which we see the inductor or capacitor in the circuit. So again, let us try on yesterday's issue whether you could solve the problem, whether it's a practice for you that whenever you go from the class with an unfinished problem, what is expected from an ideal student? That when he goes home, he should attempt and solve the complete problem, and the moment at which the students assemble in the class, they should raise their hands, say, sir, I have solved the problem. Hoping that nobody of you might have solved it, that can act as one homework. We will proceed further again in order to have some kind of further understanding. Let us see what we are doing. It is completely non-classical brute force method of solution, wherein we are not proceeding in a scientific way. For every problem, it is actually the well-established theory. It was earlier expected that light rays travel in straight line. Then it was a postulate. Then Einstein has predicted that no, they do bend near the heavy mass. So it was postulated in 1900, and when Einstein stated that light rays bend near heavy mass in 1905, but he could not prove it. For that proof, why he could not prove it? Because there was no experimental setup consisting of such a heavy mass for which the bending can be shown, and for that one has to wait for complete solar eclipse in a particular state, and in 1919 it was proved. So there are postulates, but based on the postulates all problems cannot be solved. So we continue with those postulates till we don't encounter any problem. Sometime when we encounter the problem, we have to rework. In this way we are proceeding. We have put up some set of rules. Based on that we are trying to solve the problems. If those get solved, solve, right? If those don't get solved, then we are stuck up. We will try to see whether can we add something to it. So now let's make some small change in the problem itself. And the question is, find out VOT. This is the formula. This is obviously the same one. Find out VOT. If the switch is closed at T equal to 0. Both capacitors are uncharged. Both capacitors do not possess any charge across it. So voltage across both capacitors is 0. Voltage across both capacitors is 0. Actually, what we mean by potential is also something which needs to be discussed, but at this moment I would not like to disturb your pseudo understanding. Therefore, we are resuming your pseudo understanding and continue. So now, how can we write again? Now, since there are two RC networks, the solution of the form A plus B e raised to lambda 1t plus C e raised to lambda 2t. Then voltage at t equal to 0 has to be, voltage across capacitor at t equal to 0 has to be 0, because that is the initial condition. That is not an essential initial condition. That is the initial condition which we have assumed. We can also have a capacitor charged with some different voltage, and for that the initial conditions will change, and for that also we are having solutions. Right now we presume 0 initial condition. So this is the assumption of V0t. So V0 equal to 0, V0 equal to 0 makes this as 1, this as 1. So A plus B plus C is the output voltage. This must be equal to 0. So A plus B plus C is equal to 0. So we say A is equal to minus B minus C. A is equal to minus B minus C. So immediately our assumption for voltage comes out to be V0t is equal to minus A minus B plus, so minus B minus C. A goes directly, plus B e raised to lambda 1t plus C e raised to lambda 2. This is VOT, voltage of this capacitor. Now we have to presume in this way. Yesterday's problem, same similar problem. This is I1t, this is I2t, this is I3t. Or this is actually I1t minus I2t, and by using all possible loops we can try to solve the problem. So we may make up use of Kirchhoff's laws in very interesting manner. So this is a very crucial point in the circuit, which is a major node that we can give as, say, D. Because B and C were used somewhere, so D, E like names we can give. So this is the point D. So D is a major node. So D dt will be what? What would be I2t? What would be I2t? I2t would be equal to I2t would be equal to lambda 1 b e raised to lambda 1 t plus lambda 2 c e raised to lambda 2. This is what I2t. This is I2t. So what would be VDT, VOT plus 2I2t? Am I correct? What would be VDT? VDT would be VOT plus 2I2t. That is equal to VOT is minus B minus C plus what this would be? B into bracket 1 plus lambda 1 e raised to lambda 1 t plus C into bracket 1 plus lambda 2 e raised to lambda 2. It is what VDT. It is VDT. What would be I1t now? What would be I1t? 1 minus d by dt of 1 minus VDT. Are you getting me? I1t would be d by dt of, are you agreeing with me? Voltage across capacity is 1 minus this. That is 1 minus this entire. So voltage across capacitor, I say this, I can say as capacitor C1, this I can say capacitor C2. So where? This one. 2 should be here, na? Here 2, right? 2 lambda 1. Now, what would be VC1t would be equal to 1 minus this, means 1 plus this minus this is VC1t, voltage across capacitor. What would be I1t then? Its derivative. So I1t would be equal to, this will go minus B lambda 1 into 1 plus 2 lambda 1 e raised to lambda 1 t minus C lambda 2 into 1 plus 2 lambda 2 e raised to lambda 2 is what I1t is what I1t. What is where is I2t? I2t is now, I2 is here. I1t is here. What is I1t minus I2t? I1 I1t minus I2t is this current. This being 1, this must be equal to Vd. Right? So what is VDT? This one. So VDT I have just wiped out. VDT was, I rewrite, VDT was minus B minus C plus B into bracket 1 plus 2 lambda 1 e raised to lambda 1 t plus C into bracket 1 plus 2 lambda 2 e raised to lambda 2 t is VDT. So now what we must have, VDT is equal to this current into 1. So VDT must be equal to I1t minus I2t. And in this, it's a big expression, you may match the terms. In this big expression, you may match the terms now. So what happens? What is I1t minus I2t? I1t is this. I2t is this. So it comes out to be I1t minus I2t. That is minus B lambda 1 into 1 plus 2 lambda 1 minus lambda 1 B e raised to lambda 1 t minus C lambda 2 1 plus 2 lambda 2 plus lambda 2c e raised to lambda 1 t lambda 2 t. That must be equal to what? That must be equal to VDT. What? This, no? This in the bracket. I1t is this minus this. I1t minus I2t. So minus has gone inside. So now what should happen? What should match? In this expression of I1t minus I2t, there is no constant term. Here there is this constant term. So what we must have? Minus B minus C is equal to 0. Means state where B plus C equal to 0. That one thing we have. B plus C is equal to 0. B plus C is equal to 0. B plus C is equal to 0 is one what we get. Now by applying initial condition again, we may further simplify. It is VDT. It is VDT. Then at t equal to 0, voltage across capacitor is 0. So what is voltage here? 1. Voltage here is 1. At t equal to voltage is 1. So what this must be? Also 1. Because this must be 0. So at t equal to 0, VD0 is 1. At t equal to 0, VD0 is 1. So at t equal to 0, this is this. It goes here, it goes here. So what is VD0? VD0 is equal to minus B minus C plus B into bracket 1 plus 2 lambda 1 plus C into bracket 1 plus 2 lambda 2. And this is 1. That must be 1. This must be 1. Because this is 1, this must be 1. So what we further, this must be 1. So when this is to be 1, we know that B plus C is equal to 0. So this goes straight away and we get 1 1 is equal to this one equation we get. And further what equation we get? Further we match these terms. These two terms should match and these two terms should match by coefficient wise mapping. So we are having this short blackboard. So if we match coefficient wise, this should be matching to this. That is minus b lambda 1 into 1 plus 2 lambda 1 again minus lambda 1 b must be equal to b into bracket 1 plus 2 lambda 1. Correct? Now b goes out and we get minus lambda 1 minus 2 lambda 1 square minus lambda 1 is equal to 1 plus 2 lambda 1. What is the answer to it? What is the answer? So it goes on other. In this you can make it plus. So it is minus into bracket 2 lambda 1 square plus 2 lambda 1 is equal to 1 plus 2 lambda 1. So taking minus on the other side, 2 lambda 1 square plus 2 lambda 1 is equal to minus 1 minus 2 lambda 1. Bringing it on the other side, we get 2 lambda 1 square plus 4 lambda 1 plus 1 is equal to C. Is it correct? Is it alright now? So what is lambda 1? Again it's a quadratic equation. So we may get two lambdas. One is positive and one is negative. So we are in the brute force method. So lambda is to be taken negative. Is one thumb rule you can pursue. Then find out lambda. Similarly find out lambda 2 also. Here both will come. For lambda 2 we might have, okay, find out, might have made some mistakes. Find out lambda 1, lambda 2. Let us see what happens. It is not having any charge. Initial condition of capacity is 0. Therefore, voltage across capacitor is 0. At t equal to 0, this voltage becomes 1. We are closing the switch. This voltage becomes 1. Voltage across capacitor has to be 0. So, to maintain voltage across capacitor to be 0, this must also be 1. So, Vd at 0 must be 1. So, we get lambda 1 here. We get lambda 1. Then, what is lambda 1? Lambda 1 is equal to minus b plus or minus b square
minus 1 plus minus
16 minus
1
a
upon root 2
upon 2a. That is equal to minus 4 plus or minus 2a upon 4. So what we get here? What are the values of lambda?
-1 plus -1 upon
So
root
we get 2 lambda values, right? So those are minus 2 plus minus
1 upon root
2 square root 2 minus 4 plus the 2 square root 2 upon 4. Minus 1 plus minus so we need to verify whether we have made some mistake in calculation. I presume there is, unless there is some mistake in calculation, it is not going to work like this. It will give us two negative values of lambda 1. Means lambda 1 will be one negative value and lambda 2 would be another negative value. That is actually connected to the RC. That is connected to the product of RC. Here there will be some effective product, but we get two values for one for lambda 1, one for lambda 2, and we get a equation wherein we find that it obeys some exponential form. I presume that there must be some, it needs to be solved very patiently so that not a single mistake is committed and we get to the answer. So what I feel now is that you have been well exposed to the brute force method, wherein the theme is very simple. For one reactive element, you should take one lambda and work with e raised to lambda t happens to be e raised to lambda 1 t happens to be one possible solution. So we are going for the problem rather than solving the problem. What we are doing, we are assuming a solution. When we if we decide to solve the problem, then even the class of solution not known to us, we have to solve classically. So we presume a solution of a type of the solution so that our work gets reduced to finding out few values. So what we find is that for those circuits which have only one reactive element, it works very fine. So we can take one more example with some another non-zero initial condition. So let us work through this. So this is a capacitor which has got voltage of 2 volts across it. This is a capacitor which has got a voltage of 2 volts across it. VOT is A plus B e raised to lambda t. At t equal to 0, it is A plus B and that is equal to 2 now. A plus B is equal to 2 and not 0 as it was the earlier case. So for this problem there should not be any thing which will prevent anybody to find the answer. It's very straightforward problem. VOT, what is the answer? 1 plus e raised to minus t. 1 plus e raised to minus t means at t equal to 0, what it is? At t equal to 0, it happens to be, it is 1 plus e raised to minus t. Right, at t equal to 0, it happens to be 2 because e raised to 0 is 1. 1 plus 1 is 2 and it proceeds in this manner. Actually, it's a discharging of the capacitor. Everybody got it? Whether is there anybody who is unable to get it? Straight away it is to presume, then current is to be found out. Current would be V lambda e raised to lambda t, right? There will be lambda e raised to lambda t So this voltage is IT. This voltage VOT we have presumed that is equal to A plus B e raised to lambda t. A plus B. Now it is better to have substitution initially itself. So when it is A plus B raised to lambda t and what? A plus B is equal to 2. So A is equal to 2 minus B. So VOT we can directly write VOT is 2 minus B plus B raised to lambda t. Now for resistor, this is 1. This end is 1 volt. This end is this. So voltage across resistor is 1 minus VOT. Therefore current must be that upon 1. So that must be the current. So IT is this as dictated by the capacitor. IT is 1 minus VOT upon 1, that is equal to 1 minus 2 plus B minus B e raised to lambda t, that is equal to B minus 1 minus B e raised to lambda t. Is it right or some error? A plus B voltage we have presumed A plus B raised to lambda t at t equal to 0, this being 2, A plus B is equal to 2. A is equal to 2 minus B, so this is VOT. So VOT is equal to, so voltage across resistor would be 1 minus 2 minus B minus B e raised to lambda t, that is equal to 1 minus 2 B minus 1 that this upon 1, that is this itself, this must be equal to B lambda e raised to lambda t. So what must be equal? This term must be 0, so B must be equal to 1. B must be equal to 1. B minus 1 must be equal to 0. So B equal to 1. Means if you put 1 everywhere, when you put 1 here, we get this minus goes, so lambda equal to minus 1. So the answer is 2 minus B, that is equal to 1. 1, B is 1, so 1, lambda minus 1. Is it correct? So Laplace transform is covered till what extent? Is over, finished?
D is equal to 1. G minus.
So Laplace transform theory is over completely now. Right? If Laplace transform theory is over, then Laplace transform enables us a very effective way to solve the differential equations. So we will try to see how Laplace transform means. Now again there are two approaches. First, whether we should try to further think the exact interpretation of Laplace transform in electronics engineering and then solve the problems, or vice versa. We adopt a simple approach of application, that is, the Laplace transform is very much useful in differential equation. For every function ft, we are going brute force at initial stage, wherein we should be able to solve the problem, and then what will convince us? The answer will convince us that it is the correct approach. Once we get the answer, for that answer we tally everything. That is a confirmatory test, and that will give us the what we can say confidence that the method is correct. Now when we put the answer that here 1 plus e raised to minus t, then you will find this voltage, you will find this current, you will find that at every point of time both of these match, means this voltage you will find, this current you will find. So because of this current there will be some voltage across this, that you will find, and you will find that this voltage always matches with this. Once we solve by this method also, what we will do is we will find voltage across capacitor we have found, we will find voltage across resistor, and then we will see that both of them add up to always 1. So voltage across resistor would be e raised to minus t. Voltage across resistor in this case would be e raised to minus t, because minus e raised to minus t. Voltage across resistor would be minus e raised to minus t. That have you learned P-Spice or Proteus?
Yes.
So in Proteus you can realize all these circuits. In Proteus you can realize all these circuits and get the solution. So our brute force method and also Laplace transform is a classical method, or a bypass. Laplace transform, what we can say, is a classical bypass to classical method of solving differential equations, and ours was a brute force bypass. Ultimately we should be able to find out the solution for the problems which consist of resistor, inductor and capacitor, and to which we are connecting voltage sources, maybe current sources. To that we shall come. So Laplace transform allows us to have the transform of every function ft as fs, and once we have that, we can write the equation in Laplace form, wherein differentiation is equal to s in, if I have ft is having its Laplace transform of fs, its d by dt of ft is having its Laplace transform as sfs, and then we find out the answer as say v, means vt is one function, it is another function, vot is another function of time. So when we transform everything into Laplace domain, we get the answer for vos, and that by finding out inverse Laplace transform we get the answer. So we may attempt one problem solution by Laplace transform. By that time I am sure that by rigorous homework you will convince yourself that the method which we have discussed can also solve the same problems. So for Laplace transform now, in this first go, we will not be going to analyze anything for Laplace transform. It would be just know the Laplace transform, know the inverse Laplace transform, and find the solutions. Only thing what we usually require is that d by dt gets transformed to s into, d by dt of ft gets transformed to s into fs. And inverse Laplace transform table you remember. Just like in school days students remember something, like that you remember Laplace transform and inverse Laplace transform tables. Sometimes it is likely that inverse Laplace transform may not be easy to find. For that we have to solve by partial fraction method. And I think everybody would be in a position to comfortably solve these things, because this is quite simple. So the same problem we can solve, or we may have only difference difference that we may have at the start we should start with simple thing. B00 is equal to 0. So solve this by using Laplace transform. Solve the same problem by using Laplace transform. Means what? Write a differential equation first. Write a differential equation first. This is 1. Actually this is 1 means we close the switch at t equal to 0. Means before that when we close the switch at t equal to 0, it means that we apply a waveform like this. This is called as which kind of signal? Square wave. Ut means it was 0 till t was 0 and it becomes 1 when t becomes 1. So in Laplace transform we must have considered it. What is Laplace transform of ut? Laplace transform ft equal to ut. What is its transform? One upon. Are you comfortable with Laplace transform of pairs? Yes or no? Then what do you learn? Ft equal to ut. What is Laplace transform? Find out Laplace transform then. Find out Laplace transform for ft equal to ut. You may solve it on the last page. Ut is that function which is 0 till t equal to 0 minus and becomes 1 at t equal to 0 plus. So find out the integration. If Laplace transform is equal to ft is to minus st integrated. So how to write differential equation now? Let us first for this whatever is available here is say V in T. V in T is this. This is VOT. So V in T minus VOT upon 1 because the resistor is equal to, this is the current, right? This is equal to dVOT by dt. Right? That is dVOT upon dt plus VOT is equal to V in T. Then we take Laplace transform for entire thing. We do not know VOT, but its Laplace transform would be VOS. Its derivative. So Laplace transform dVOT by dt would be S into VOS. This S into VOS which we don't know. Plus its transform is VOS is equal to V in S. So what is VOS now? VOS into bracket 1 plus S is equal to V in S. So we get the Laplace equation that VOS is equal to V in S upon 1 plus S or S plus 1 is equal to terminology. So what is V in S now? What is V in S? What is V in S? Now since V in S, what is V in T? UT means it is 0 till t equal to 0. At t equal to 0 we are making it 1. So V in S is 1 upon S. V in S is 1. So now or this we can put here separately. That is 1 upon S plus 1 into bracket V in S. is called as the transfer function, or we can have VOS, we can take ratio upon V in S is equal to HS, that is the transfer function of this system, right? So if you know V in S, what input you apply, based on that we will be getting the output in Laplace form. So this is equal to VOS. VOS would be now equal to 1 upon S plus 1 into 1 upon S. Why? Because V in S comes on this side and V in S is 1 upon S. So it is 1 upon S into S plus 1 is the VOS. For this I do not know the inverse Laplace transform directly. But I can have these partial fractions, and I am well exposed to that, wherein if I have 1 upon S or 1 upon S plus A, for that I know the transform. 1 upon S plus A is Laplace transform of e raised to minus 8. 1 upon S is the Laplace transform of e raised to 0 t, that is 1. Actually ut is okay. I understood you found it somewhat difficult because I started with ut. If it's Laplace transform of 1, you might have understood it very easily. So what we get, this we have to write as partial fraction, a upon s plus b upon s plus 1 is equal to 1 upon s into bracket s plus 1. How will you find a and b now?
S is equal to 0.
A is equal to
1.
1 and b is equal to
Minus 1.
minus 1. So VOS is equal to 1 upon s minus 1 upon s plus 1. That is equal to 1 minus e raised to minus t is the answer for VOT, inverse Laplace transform. Inverse Laplace transform is this. Actually, there is one assumption we had made. In the differential equation, Laplace transform of derivative is s into Laplace transform of original function minus what? d by dt of ft. Have you studied this Laplace transform property? If ft is transformed to fs, what is the Laplace transform of d by dt of ft? Is equal to s into fs upon minus what? Minus, somebody said it, so it must have been covered. What is that? F of 0. What is the value of the function at t equal to 0? This we are assumed to be 0. So we wrote it to be s into fs. So we assume that the output at t equal to 0 is 0. So this was the answer. Otherwise the answer changes. With this now, we try to study by putting this as L. Instead of R, put this as L, and then you will find that the Laplace transform will give rise to a sinusoid solution. Recording off.